Welcome back to Algebra 1. We're doing Chapter 3, Section 4, and we're learning to do the classic thing in algebra, solve for x. So we make sure that there's an equal sign and some x's, we're ready to go. And how we do it is first we ask ourselves, why is it ugly? And then we try to fix it, and then we say, why is x not alone? Now this one is ugly. What's ugly about it? It's got x's on both sides. So the first thing we need to do is gather those x's together, and for that we have a special song. Gathering up your terms, and yes, this one has a dance. Stowing away the time, I don't know what time has to do with it. Gathering up your terms. So we're going to gather these x's together, and if there's no other determining factor, I'll always usually do the littler number toward the bigger one, and 2 is littler than 7. I don't worry about positive and negative, so I'm going this way. How you move things is by doing the opposite. This is a minus or a negative 2x, so the opposite is plus 2x. When I do to one side, I do to the other. Those cancel out. 7x plus 2x is 9x, and then I bring down everything I didn't mess with. Now, why is x not alone? It's got times 9 and plus 19. We always start with what's further away and move towards what's closer. So the opposite of plus 19 is minus 19. When I do to one side, I do to the other, then those cancel out. 55 minus 19 is 36. I bring down what I didn't mess with, the 9x. Why is x not alone? It's being multiplied by 9. What's the opposite? Divide by 9. When I do to one side, I do to the other. So 9 goes, what times 9 is 36? X equals 4. Whoop, whoop, whoop. All right, good with that? So if you're following along within the book, that was example 1. And remember last time I told you, how you check it is you put it back in and see if it makes a true statement. I don't do that. Doesn't work with my dyslexia. So I just check it by looking in the back of the book and see if I got it right. Alright, because with my dyslexia, I'll just flip it twice and then I'm all disappointed because I checked it and I was still wrong. Alright, so why is this one ugly? Because we have x's on both sides of the equals. This time, I'm going to move the 9 to the 6 because I want x's on one side and bare numbers on the other. So the opposite of minus 9x is plus 9x. What I do to one side, I do to the other. So 80 equals 15x. Why is x not alone? It's being multiplied by 15. So I divide both sides by 15, the opposite. How many times does 15 go into 80? Well, 1, 2, 3, 4, it's over 5. What do we got going on here? Let's see what they got. Yep, they left it doesn't go in evenly. So it's just 80 over 15, and we can reduce that, and x equals 16 over 3. And let me show you something on your calculator real quick. If you have a fraction, okay, like this, it says we're doing, on our calculator, we do 80 divided by 15, and it tells us 5.333. But we need that to be a fraction. You go to this button that says math, which is ironic, because isn't it all math? So you push the ironic button, and the number one thing says arrow fraction. That's turn it into a fraction. You hit enter, and it gives you the answer, 16 over 3. So your calculator will reduce fractions for you. Isn't that great? Don't you just love your calculator a little bit more? All right, let's do another one. Okay, hopefully we can get through all of these. All right, so this one, what's making it ugly are the parentheses, so I need to do the distributive property first. 3 times x is 3x. 3 times 2 is 6. Now then, we've got x's on both sides, so let's get them together. I'll move this one over there, minus 3x. Those mark out. I'll bring down what I don't mess with. But look, that one marks out too. Huh. I got something weird and true. 6 equals 6. If you get something suddenly, all your x's go away, and you get something weird and true, the answer is infinite solutions. What it means is if we graph this, these are the same line, and they're touching each other in infinity places. Let's try this one. X is on both sides, so we're going to get them together. Minus x, uh-oh. We end up with 2 equals 4. Does 2 equal 4? No, I'm not sure they have $4 than $2. Wouldn't you? 2 does not equal 4. If you're doing a problem and suddenly everything starts going away and you get something that's not true, the answer is no solution. And you can abbreviate it like that. Which means that, we'll learn later what that means graphically. It means that they don't touch each other. Where that one touched each other everywhere, that one doesn't touch. That probably doesn't make sense. Don't worry about it. Just know you get the right no solution, which is fun because you feel like you're getting out of math. It's always fun to get to not do math. Almost as much fun as doing math. See what I did there. Alright, so what's wrong with this one? We need to do some distributing. So I gotta draw my parentheses on. 4 times 1 is 4. 4 times negative x is negative 4x. Negative 2 times x is negative 2x. Negative 2 times 1 is negative 2. I have x's on both sides, so I have to gather up the terms. I'm going to start with these. Negative 4x plus 3x is negative x. I brought down what I didn't mess with. It's negative 1x. Now I have negative 2x minus 2. I'm going to get them together. I'm going to move the smaller one to the bigger one. Plus x plus x. Those mark out. 4 equals negative 2x plus x is negative x minus 2. Now, why is x not alone? 2 things. It's got a minus 2 and it's being multiplied by an understood negative 1. We're going to start from what's further away and work toward what's closer. The opposite of minus 2 is plus 2. What I do to one side, I do to the other. I'm doing it too fast. 4 plus 2 is 6 equals negative x. Why is x not alone? Because it's being multiplied by an understood negative 1. What's the opposite? Divide both sides by understood negative 1. Those cancel out. This becomes negative 6. Alright? Let's try this one. Now, see how that is a fraction? We hate fractions. So how we can get rid of it is by doing the opposite, which is flip it and multiply, as long as we do it both on both sides. So on this side I'm going to multiply by 4 over 1, and on this side I'm going to multiply by 4 over 1, which is the same thing as 4. And I can get rid of that. Yay! So I'm going to bring down what I didn't mess with, 12x plus 16, and I'm going to multiply 4 times this. But first I'm going to go ahead and distribute that before I do this. So this is 10 minus 3x plus 6, negative 3 times 6, negative 2 is positive 6. Now I can multiply a 4 times all of this. I could get that together first. I could do 10 plus 6 is 16. 16 plus, oops. But let's just do it a little bit and then get them together. So I have 12x plus 16 equals 4 times 10 is 40. 4 times negative 3x is negative 12x. And 6 times 4 is 24. I like that one because it's a cheer. 6 times 4 is 24. Woohoo! Yay! Alright. So now I need to gather some terms. 40 plus 24 is 64 minus 12x equals 12x plus 16. Minus 12x, I can do plus 12x to both sides. This is 24x plus 16 equals 64. So I have to do minus 16 from both sides because I got to work from what's further away to what's closer in. So we'd have to borrow 1, make it 14. Minus 6 is 8. 5 minus 1 is 48. So 24x equals 48. Oops, gotta move that. Divide by 24, divide by 24, x equals 2. Isn't that satisfying to do that big ugly problem at x equal 2? There is one more problem that's a word problem in your book that we're going to skip right now. I'm going to start the next one because the next section is about word problems, and we're going to start with that one. All right? Math is fun.